All right, today we're going to be looking at 7.2 applications of the normal distribution. And for the most part, we're going to be looking at how to find the area under the curve. And we start out giving you the standard normal variable, which is z. So anytime we see standard normal, this is z. It's given by x minus the mean divided by the standard deviation. This will give us a z-score, and we will find the area under the curve. So we have a table that we'll be using, and most of the time the table is telling you the area to the left. Sometimes you might want to find the area to the right, and we will talk about how to find all of those parts. When we find a z-value, so we do x minus mean divided by standard deviation, we will get some value. We're going to round it 2 decimal places, and we will go to that table. So for example, this is saying we got 1.3. The second decimal place was a 3, so you go down the column, find the first decimal place, 1.3. You go across that row until you get to the column that matches the second decimal place. So 1.33. The area to the left indicated by this number would be 90% or 90 or 0.9082. If we wanted to find the area to the right, we would do 1 minus that. So the whole bell curve is 100%. 1 minus the area to the left is equal to the right. In the text, they give you several examples. Each time you're going to use the z formula, x minus mean over standard deviation. You'll find z values, and then we can find the area under the curve. Now, there's different scenarios. We might look for the area between two numbers. We will look for the area to the left or the area to the right, or we might also look for the outside area. So the area to the left of one number and the area to the right of another. And I think they're showing you examples of each of those types, so right here. And then we will model that for you shortly. You can do it with technology. We can also do it by hand and using the chart. Now sometimes we might use the z formula, and we might want to find the x value. So we'll do a little bit of algebra and manipulate and work backwards to find the x value if you're given z. So using the standard normal formula, z equals x minus mean divided by standard deviation, we can manipulate that. They multiply by the standard deviation and then add the mean instead of subtracting it, and we can get that formula. The next important thing is the notation z sub alpha, which you'll see that in the section. Z sub alpha is telling you the area under the curve to the right. So this is what that is, and so we'll look at how to solve that. And then this is how to find it with a calculator. So let me model a little bit of this for you, just to kind of show you what we've talked about. So you will be given some formula, and that's going to end up being the normal curve. So the normal curve is just this bell shape. The standard normal, once you do the z formula, which is z equals x minus mu over sigma. This shifts your graph so that the mean is always 0 in the middle, and we have -1, -2. Your standard deviation is going to be 1. So your mean is 0, your standard deviation is equal to 1 when we do standard normal. I'm going to go -3. We got +1, +2, +3. So this would be your standard normal curve. If we wanted to find area to the left. That's exactly what our table gives us. There's different scenarios. Let's say I want to find the area to the left of negative 1.23. There is a table in the textbook. Let me just pull it up within the My Math Lab. So there's two tables. There's a negative side. You can see these are all negative numbers. And then there's a table 2, which goes over the positive side. And so the positive side just goes further to the right. So if we wanted to find the area, let me minimize this. I'll go ahead and make this half. So if we wanted to find the area to the left of negative 1.23, which would be this side, it's going to be less than 50%, okay, because half is 50 and the right half is 50. We do know it's going to be less than 50%. We're going to look at the first table, which is the negative numbers. I'm going to go to negative 1.2 and then go to where it meets column 3. So I'm scrolling down and notice it goes 0, 1, 2, 3, and it counts all the way up till we get to 9. So I'm going down to negative 1.2. This would be 0, 1, 2, 3. So this would be about 10% or 0.1093. So this area would be 0.1093. The areas are always going to be positive. So I can do this area to the left or area of a positive and to the left. One thing I also want to show is area to the right. So this is area to the left. That's what the table shows. If I want to find the area to the right, I can do a negative or a positive. Let's just say this is 0 in the middle. Let's say I want to find the area to the right of 0.72. So this time I want to find the area to the right. What we need to be mindful of is that the table is going to show us the area to the left. This is what the table is going to show me. So if I look up 0.72, which I'm going to close this, go to the second table, I'm going to look up 0.7, and this will be 0, 1, 2. So this area right here, 7642. This is the area to the left. We want the area to the right. So if I want to find the area to the right, you always will do 1 minus the area to the left, which would be 0.7642. So if I do 1 minus that, you can use a calculator, it will give you 0.2358. 0.2358. Now, anytime you want to find the right, the area to the right, you're going to do 1 minus the area to the left, which is what you get from the table. Also, the bell curve has a symmetric property. So the area to the right is equal to the area to the left of the opposite of that number. So what that means is I could look up negative, the opposite of that, which would be negative 0.72, and the area to the left, this is like a mirror image, the area to the left of the opposite is going to be equal to the area to the right. So if I was to look up negative 0.72, it should give me the same thing. So I'll go here and look up negative 0.7, this is 0, 1, 2. You see that 0.2358 matches with what we got here. So just be aware, 1 minus the area to the left will give you the right. You can also look up the opposite. You get the same thing. So this is area left, area right. Now we might want to find the area in the middle. So let's pick 2 numbers. let's say we want the area between 1.51 negative and positive 1.28. So let's say I want the area in the middle. How do I find that? So what you will do, if you look up 1.28, it's going to give you the area from here all the way to the end. It's going to give you everything. We will also look up the area to the left of negative 1.51, and we will subtract. So if I subtract this piece, it will leave me with what's in the middle. So I'm going to find both of these and then subtract them. So we're going to look up, since I'm already on the negative, let's go ahead and look up negative 151. So negative 1.501. It's going to be 0.0655. All right, so that's 0.0655. All right, we're going to look up 1.28. So 1.28 is going to be all the way next to the last row. So we're going to go down 1.2, and then I got to scroll over. Can I make this a little bit bigger? There we go. I need to be able to get that on there, make sure I'm on the right row. 1.28. So it's going to give us 0.8997. 0.8997. And so I will subtract these two. 0.8997 subtract 0.0655, and that will give us 2438. So the area in the middle between those two, you would just subtract. And then the last type of problem you might see would be the area on the outsides. And when you do this, you're going to add them up. So let's say I want to find the outside of 2.01. I want to find left of that, and I want to find to the right of 2.16. So this is going to be negative. Okay, it's on the left of 0. This is positive. Now when I use these, remember the area to the right, I would have to do 1 minus the left, area to the left, or I can look up the opposite. So what I'm going to do is I'm going to look up negative 2.16. It should be equal to, that way I can use one chart. So area to the left, I'm going to be on the negative chart, negative 2.01. So 2.0, that's 0, this is 1. So 0.0222. So this area right here will be 0.0222. All right, and then the area to the right of this number is the same as the left of its opposite. Remember, mirror image, they're symmetric. So I can just look up negative 2.1 and then 0, 1, 2, 3, 4, 5, 6. So we get 0.0155. 0.0154. I don't know why I said 55. 0.0154. All right, so we got both of those areas. We need to add them up when we want to find the area on the outside. So I'm going to find 0, 2, 2, 2. We're going to add that to 0.0154. 6, 7, 3, 0. So the area on the outside we would have to add. So this is all 4 scenarios. We'll be doing this over and over again. Also incorporating that to finding this value. So in order to find these values that I'm using and getting from the table, we have to do this Z formula. So they'll give us x minus mu over sigma. Sometimes we'll have to compute it. Sometimes they may just give it to us, but that is the process. All right, so now let's jump into my math lab and start working those examples.